Today we're going to take a look at launching the Xilinx ISE. We're going to create a project. We're going to create a schematic inside that project, and then we're going to look at how to synthesize it. So we're just going to do a real simple, quick walkthrough of the logic function that I've got written down here. So first thing we need to do is we actually need to double-click the ISE Project Navigator shortcut on the desktop, and that'll launch ISE for us. Okay, now you can actually have it set up to launch your last project, which is what I usually do, especially if you're working on something for a while. First thing you want to do is go to File, New Project, and then we'll put in the name of our project. In this case, we'll call it Schematic Project. Okay, now down here, you may or may not have this selected already. You have a couple of options for top-level source. You have HDO, Schematic, EDIF, or NGC/NGO. What we're concerned about today is Schematic because that's going to be our top-level source. So select Next. And then you'll want to select your board that you're designing this for. We're not actually going to put this on a board, but the board that I usually work with is the Spartan 3 XC3S1200E. We're not going to worry about that right now. So just click Next and then Finish. Okay, now it's giving us an empty project. We have nothing here, literally. So now what we're going to do is we're going to go over here to the Hierarchy and under the Design tab. And we can right-click in here to do it, or we can actually click New Source over here. And so what we want to do, we have all these different options of different file types that we can create. And what we want to do is we want to create a schematic. So we'll call that our schematic source. And we're going to add it to the project. Click Next, Finish. And now we've got this nice big open empty plane here where we can drop our pieces. I'm going to zoom in here real tight so that we can see everything well. Now over here on the other side of the screen, we've got all these other parts, or these other options that we can work with. So first part that I need for my logic function is NAND. So let's grab a NAND. So we just scroll through our list here of symbols. Now what we can do is we can actually go through and narrow it down because we're looking at all of them right now. So to make it a little bit easier, let's select logic for our categories because that's what we want is a logic symbol. So let's go on ahead and go down here and grab our NAND. Let's just grab a NAND 2 because that's what we're going to work with. So then we click on it and it gives us our NAND. And then to drop a NAND in, you just click once. And if you need another one, you click again. And then in my case, I'll use another one. So we'll click again here. Okay, so now we have these 3 NAND gates sitting here. I'm also going to need an inverter. So let's go on ahead and grab. Actually, I'm going to need 2 inverters. So let's go on ahead and grab a couple inverters. Let's see, we'll need one here. And if you want, you can go on ahead and connect it by dragging and just lining it up with the square on the end of the NAND input. So we'll go ahead and put one there, and it'll automatically connect it. And we'll put another one here. Okay, so now we've got all of this set up here, but we've got all our symbols laying around, but we're missing all the wiring in between. So let's go ahead and put that in. And to do that, you click right here on this little, looks like a pen with a red line it's drawing, and that's to add a wire. So now what we want to do is we want to click once on the square where we want to start, and then double click where we want to close the wire. So we do that on each one of these. Connect, and then we're going to go on ahead and drag some wires out. If you just click and drag when you release, it'll release the end of the wire. So that's a useful way to do it too. So we'll drag all of our wires out here. And then we'll put one out for our output. Okay, so now we have all of these bare wires here, so let's go on ahead and put some inputs and outputs on it. Whoops. Now, this is the I/O marker button here. You just hover over it, it'll tell you what everything is. Like pretty much any modern software, it'll tell you what that button does. So right here, we want to click on Add I/O Marker. Now, it tells you right out when you click near the end of a branch, what do you want to do. You can add an automatic marker, add an input marker, add an output marker, add a bidirectional marker, or remove the marker. So we're going to go ahead and be real specific, and we're going to say we want to add an input marker. So we need 3 input markers. So we're going to go ahead and connect them right to the end here of our wires, and it's going to automatically name them. Okay, so we've got those, and then we need an output marker. So let's click that, select output marker over here, and then go over to our output, and then add it right onto that square. Okay, so now let's go ahead and rename these so they're a little bit easier to work with. So if you double click on it, and then click the name down here under nets, you can actually change the name of it. So we'll change that to A. And then hit OK, and it changes it to A for our schematic there. We'll change this one to B. And then we'll change this one to C. And we'll change our output to F, just for clarity. Okay, now we still have one bare here. That one actually happens to be a connection that we want to make to A. So let's go on ahead and drag it up to A and make that connection there by double clicking. And it connects it in, so we've got that wire dragged down through. So this is our schematic right here. Now you'll notice the little star there. That means that we haven't saved it, so let's go on ahead and save it. And then we can verify that we've got all of our connections made up nice by going over to Design and then selecting our schematic. And if you look down here, you'll see the label synthesize-XST. So let's go ahead and synthesize it. You can do that by double-clicking on Synthesize. And that just verifies that our circuit is a working circuit. So as long as you don't, mess up putting your circuit together, then you'll be fine there. So one thing that we can do is we can go and look at our RTL schematic. Now this is what would actually be put out on the FPGA. So if you double click on the RTL schematic, it will bring up what it looks like on the device. So the first thing it shows us is this box with 3 inputs and 1 output. So that matches up with our design. So if you double click on the box, it'll take you inside the box. So you can actually see that it's using the exact same layout that we were using before, with our 3 NAND gates and 2 inverters, and that gives us our output. Now, if you put in a design that's not fully optimized, it will change your design to a more optimized state, which is a handy part of this software. So that's it for that part. Yep, that's it. So I hope you learned something, and I hope you enjoyed the video.